Hello, I'm Bryan with Capital Robotics. What I'm standing inside today is a fusion arc weld cell that we can provide to you to reduce your weld costs. Wanted to go over a weld audit, which we call a weld cost analysis, that shows a return on investment. Let's go ahead and open the weld cost analysis. So there's a couple different things for criteria we need here. What type of material are we going to be welding? Steel, stainless, or aluminum. Material thickness, different gauges, different thicknesses, plate, and then a monthly quantity. So in this case, based upon the part we're showing here, we have a couple different welds. We got different measurements here. We got 4 vertical welds, 2 inches, as you can see downhill. We're not going to be weaving it. 2 2-inch welds on the sides. These are butt welds on the side, illustrated here. 2 5-inch welds, which are fillets, which are going to be these tabs on the inside. And then 4 half-inch fillets, which are the inside of this portion in here. So basically, again, what it's showing is to do all that with the travel speed listed, it's going to be right over a minute of weld speed. And then the total cycle time is going to be about 1.25 minutes, so about 1 minute 15 seconds. So to do my quantity of 88 times per month, it's about 2,100 inches of weld. It's going to be about a quarter day to do that production. So the next part we labeled it the base anchor. Again, it's a steel part, 12 gauge. We're doing about 200 a month, which is only about 50 parts a week. In this part, we have 4 3-inch welds here, so on and so forth. 1 diameter, 2-inch diameter on top. Showing the weld speeds again, we're not weaving, and then the different weld types as well. Downhill fillet, butt welds. So to perform this part in the automated robotic process, it can be about 1.5 minutes of total weld time. But again, using cycle time analysis, it's going to calculate right under 2 minutes of movement. So we're actually calculating the time from the start here to stopping here, the movement of starting to the next weld as well. So to do the monthly requirement of 200 a month, 7,500 inches of weld approximately, it can be about a day's worth of work. So a full month's production in 1 day. That's powerful. So the third part we have is the NEMA box enclosure. A lot of our customers have different style boxes, fuel tanks, what have you. Construction of this. Again, we're looking at steel. In this case, it's going to be 11 gauge, a little bit heavier. 200 a month. Basically, we have 4 4-inch welds and 4 1.25-inch welds. So even though you would think this doesn't have a whole lot of linear inches of weld, by the time you calculate 200 a month, it's about 4,200 inches of weld. So again, to do the monthly requirement here, we're looking at a half day of production. So the last part of the analysis is the aluminum pole bracket. 1/8 inch thick, aluminum material. Doing about 100 a month, again, about 25 a week. And again, not many welds on it, but still 2 4-inch welds. We're not weaving fillet. It's going to be about 1/3 of a minute, so you're looking at right at 20 seconds. So to do 100 a month, it can be just under a couple hours to do that part. So if we go now to the analysis tab, so now this is kind of where we can calculate the total number of parts and everything, units required. So although we only had very lower volumes for lot sizes, it's a number right under 600 parts a month. Production days to complete, under 2 days to complete it. Total inches of weld, you're right at 15,000 inches of weld. So the way this spreadsheet calculates everything is based upon human efficiency and human speed of welding versus automated efficiency and automated speed of welding. So on the automated side, we're going to be about 80% efficient. That means out of a 10-hour shift, you're welding about 8 hours a day if you can feed the machine correctly. The human's going to be around 20%, 22% efficient. It's not that anybody's lazy. That's saying from moving from part to part, lifting up the hood, taking breaks, using the restroom, what have you. So my average speed of welding can be about 26 in this case. This customer was TIG welding this part, so you're going to be running about 8 inches a minute on that part, and then on the MIG process about 8 to 10 inches a minute as well. So based upon that criteria, we're looking here, the burden rate is going to be about 60 bucks an hour. So to perform 14,568 inches of weld manually at the manual efficiency and manual speed, it's going to be about $10,000 per month. To do the same thing robotically with my efficiency and my speed, we're looking at $830 per month. So your monthly yield is going to be about 9,700 bucks. Total investment of $115,000. Big thing here, ROI is less than 12 months. So as you can see, justifying a fusion arc weld cell by Capital Robotics is very achievable, even with low lot sizes. We're only utilizing the robot 8 hours a day, 1 shift. As you can see before, there was only 2 days being used out of the work month, thus leaving 18 days to fill up the robot with even more product. If you'd like more information on how we can help justify your machine, please contact Capital Robotics.